So what I want to talk about in this video is pretty much a walkthrough on what I'm thinking when I'm doing a bit of fault finding on control valves. So specifically the ones with positioners on them, electro pneumatic ones obviously. So looking at this slide that I've made, first we have a problem that arises, somebody telling you that the valve is not working, they're suspecting something's wrong. On a sideline note next to that, you need to get permission to operate the valve during your fault finding and calibration process, because if the plant is running while they talk to you about this, you might not have free rein to completely open the valve or completely shut the valve, even if it's already in a bad state. Obviously it's causing some kind of grief, but you could be making it worse, so they might have to shut something down for you so that you can have a look at this. Good communication is obviously what's required to get started. So then you'll have to gather information about the problem. You need to talk to whoever came up with the idea that there's something wrong with this control valve. Have they gone for a physical look? Can they see something in the process not working well, like a tank overflowing or not filling up at all? There would be telltale signs, but that would lead you to understand, is it maybe stuck halfway open? Is it all the way open? Is it all the way shut? Is it very irregular, or what's going on? So once you've gathered some information, you can obviously go and investigate. Now when you go and investigate, the first thing that you need to do, well, two things that kind of go hand in hand. I'm going to do one before the other one. It's not always necessarily going to be like that. You're kind of going to get through both of them together, or eventually, especially when you start seeing things wrong. So if we start visually, as you walk up to the control valve, you have a look to see the supply air line. Is it connected? Is the isolation valve open, meaning is the air actually going to the unit? Sometimes there's a shutdown for something else, or somebody thinks, oh, this is noisy, and they just turn it off. So it could be just the air is turned off. Also have a look at the air lines, make sure they're connected, and make sure they're connected correctly. If you know which way they go, they could have just come out, could be missing. These are all things that could happen. Also visually, you're having a look to see if any of the mechanical parts are not how they're supposed to be. So is the feedback arm connected? Is it tight? Just looking at the bolts and the mounting. Also what you can look at is just in general anything that looks like it's wrong or out of place. The other thing to do is to listen. Now we use listen because we're using compressed air, and compressed air can make a noise, and sometimes it needs to make a bit of noise, and sometimes it doesn't need to make a noise. And you should know after a while what is required from the air. If it makes a lot of noise, then you know, oh, something's leaking out somewhere. So that's something you look for. Is there air leaking out somewhere? Can you hear that? And if you can hear it, then you're going to have to move your hand around all parts to feel if you can feel where the air is coming out. Obviously stay away from any moving parts like the feedback arm and things like that. You don't want to get yourself pinched in there. Also listen for noise while they're trying to operate it from SCADA. So while you're there and you've done what you can visually quickly, you might ask the operator if they could try and operate that valve, get them to move it to 0 or 100%, 50%, somewhere other than where it is, and then you listen Now, can you hear anything with the air? Can you hear the positioner or the actuator, or the valve? Not just the air, but just mechanically, can you hear something? Maybe you can hear it trying to go, or it's just slamming from one position to the next rather than controlling. It's just really moving a lot from open to closed position and no control in between. I've seen that happen before. The other thing to listen for, it's something that you can listen and also can see, and if it's hunting meaning it's just going back and forth, like it can't find the right spot for it to be. So just opening a bit, closing a bit, just going up and down the whole time. When you're looking at that, you see how quickly it goes and the nature of the movement. So what I mean by that is, if it's just constantly doing it, it'll tell you one thing, and if it only happens that it's hunting open and shut when they're trying to control it, that tells you something else as well. So maybe just quickly on that, in my experience, if it's hunting quickly back and forth the whole time, making a noise, you can hear that. That's probably this internal spring that connects to the pilot valve that will be missing or fallen out. And if it sweeps from open to shut, doesn't matter what percentage output you decide to do, if it only goes open and only goes shut, there's a very good chance either the airlines are the wrong way around, or the feedback arm is not connected properly and you're not getting that back. Okay, so once you've gone past all those points, what you do is now, so the next slide what I have here is what to check to determine the nature of the problem, right? So if this quick visual and listening didn't get that much for you, or you've picked up some stuff, obviously you can now open up the cover and you can force the positioner open or closed manually. And there's two ways of doing that. You can toggle a little arm, and I've shown that in other videos, and I can explain that again later if needs be. You can toggle that open and shut, and that'll tell you something, you know. So if this actually works, if you can toggle it open and shut and somewhere in between, that means that your problem lies before the pilot valve. And the only things before the pilot valve really is the coil and the signal and the cabling. Right, but if toggling this does not work, when we're looking at that, either the pilot valve itself is sticky or stuck, or there's bypassing or leaking happening through the actuator. But you hear something trying to move but it's not going, and if you can hear something trying to go but it doesn't go, that's normally like the actuator, or the valve could be physically seized and everything's trying but it's not moving. If you hear no air happening when you toggle, that is definitely the pilot valve. Right, so back to the pilot valve. If that's sticky, you can use the air supply to test it. How you do that is you obviously isolate the supply air first. You remove some air lines, just make sure you know where they go back, and you put the supply air line straight onto the actuator, and you see if you can force it open or closed, and vice versa. And if you can do that, obviously from the actuator down to the valve, we're okay, and the problem would lie before that. So if your actuator is bypassing and leaking, with that same test you'll be able to see it, because if you put air in the one port, some air will come out the other port when it's not moving. And when it is moving, air will come out there, because with the movement it forces the air out of another chamber. But if there's air blowing out and nothing's moving, then you know it's bypassing through. Right. So back up to what to check for. The next thing is check for the milliamp signal. So if you realize that everything is mechanically, physically moving, and you've toggled the pilot valve and that works, you've got another problem. So you check the milliamp signal. If the signal is present, if you can measure the milliamp signal that corresponds with the output of the SCADA, that means that your coil is probably open circuit, or that the problem could be pneumatic still. If you didn't check all the pneumatic stuff, all the air stuff first, if you went straight for the signal, that's why I'm saying a problem could still be pneumatic, because you might not have gone that far or checked that. You might have started with a signal first. But if the signal is there, and if the coil resistance is good, then that'll tell you pneumatic problem if you haven't checked that already. From there, you have a look. If the signal is not present, it's then the wiring or the output in the PLC. So now you're going to have to test that wire, that cable, wiring back to the PLC, or run back to the PLC and make sure that you're getting the output from that PLC. Right, so the third problem that we're looking at is, I've spoken about it a little bit before, is the sweeping, open and closed, or hunting. If it sweeps only when you're trying to change the milliamp signal or the output, and it swings open, and you try a few other numbers and eventually it swings shut, and then you do it again and it swings open like that, that has to be with the feedback arm. It's not feeding back into the positioner. The next thing that you can check for is if you have a problem with the swinging back and forth, is the plate, the direct acting and reverse acting cam plate. Now this ties back in with gathering information about the problem, because sometimes some of the information that you might get will be somebody saying, look, we had this problem yesterday or over the weekend or night shift, and it hasn't been good ever since. As well, somebody tried to change it out, it didn't work. So they might have put this thing in and it might have gone the wrong way. They might not have checked the old one to see how that one's plate was, so you might have the plate going the wrong way if you have a new one, or somebody's turned this plate over when they tried to do a bit of fault finding and they couldn't work it out, and they left the plate in the wrong position. Alright, now the last one I want to have a look at is if it's hunting continuously. So it's just going back and forth, back and forth, back and forth. You can just hear it just going. Nobody's doing anything, no one's changing anything, and it's just going open shut, open shut. Then there's a very good chance that spring is missing. If that spring is not missing, see if you can force it open or shut. I will do a video on open and shut as well. If you miss something that I'm talking about, please let me know and I will direct you to the correct video, or I can just do a video again, or maybe I've just missed it and I'll upload something. Alright, so you can check the spring, and potentially the pilot valve could be faulty as well. So yeah, this is pretty much my approach to electro-pneumatic control valves. The type of valve doesn't really matter, the brand of actuator doesn't really matter, as long as it's electro and pneumatic. This is pretty much how I approach it. Enough information taken with me, and if I didn't get any information, well, with this process I can honestly find what I'm looking for. I hope you guys enjoyed this video. Like I said, make a comment if you need to. I'll get back to you, see what I can do for you.